Hi friends, now the next topic is to look at the data which we are getting through the sensors. That's sensor data. Sensor data is the output of a device that detects and responds to some type of input from the physical environment. So whenever we want to interact with the reality, then we must interact with the physical environment. So to understand the nature of environment, we need to study it. To study it, we need to measure the parameters, and for measuring the parameters, we need to sense it. So these are the data which are generated after sensing the physical reality, and for doing that, we do require special components called sensors. So we do have sensors that respond to the input from the physical environment and present us the information in the electrical form, so that the next step can read it conveniently and do the needful. This output produced may be used to provide the information, or can be an input to another system, or to guide any process. So today we have innumerable types of sensors available, be it monitoring the traffic, or we have sensors for airborne activities like imaging, or even to fly an aircraft. We do require a lot of parameters to be maintained under control. So for controlling them, we do have to understand what is the value of it. For that, we need to read and record. For that, we need sensors and all that. Yeah, of course, health monitoring. We do have today a lot of developments done in creating various sensors, various equipment that help us to monitor our health. And of course, the whole process was began with industrial process control. When we wanted to control the industrial process, we do need to read the parameter values and make sure to maintain those under some particular format, under some particular levels and all that. So for that, we do require that. We today, for security reasons, we are using webcams and all that. Yeah, we have a lot of data stored, and we can store this because storage is cheaper today. So the available data from the sensors can be stored onto the storage. We have a lot of data can be collected from environmental, like wind speed, wind direction, rain, humidity, temperature, and many such things can be measured, controlled, monitored, and all that. And satellite based, many such things are available. So basically, sensors are the devices used to convert. So basically, technically, they are called transducers, convert one form of energy into another form of energy. The energy may be in the form of temperature, may be form of pressure, or any other thing. So we do like to convert from one form to other form, and we have sensors, and for sensors we use transducers. So there are various transducers available to measure temperature, to measure pressure. Then there are various techniques to measure the length, measure the weight, speed. Yeah, we have today a lot of gas detectors. So I, for the security, safety reasons, we do have today gas detectors, accelerators, acceleration measurements, and all. So many are possible. So some examples, if you want to know, just to get an idea how diversely these can be applied. A photosensor is a device that detects the presence of visible light, infrared light, or even ultraviolet energy. So it can be used for visible light. A photodiode phototransistor can be infrared, so like IR detectors. Even we can use for ultraviolet UV energy. LIDAR is like a radar where radio was used. Here, LIDAR is a laser-based method for detection. This is usually used for range finding, like distance between two objects. Mapping typically uses a very low power, and it's a high safe pulsing laser working in conjunction with a camera. Yeah, most important thing in today's world is our CCD. That's a charge coupled device, very commonly used in the cameras, which we call CCD camera. So one charge coupled device is used for measuring the intensity of the light at one particular point, a cell of a picture, in short we call pixel. So each charge coupled device will convert the light intensity into an electrical charge, and the intensity of uh, which is related to color in the color spectrum. So we have basically three types of CCD. So one is more tuned towards red. So the charge coupling or this charge accumulation is more active in red light, one more active in the green light, one more active in the blue light. So three together can form one RGB. So the three data together can represent any color shade of the visible spectrum. Same way, when we talk about electrical systems, we have smart grid sensors that provide real-time data about grid conditions, detecting any outages are there, faults are there, and a overload or triggering alarms and all that are used so that the whole electrical grid can be put under control without much disturbance, and make sure that the whole grid works smoothly. If at all there is any problem at any one part of the grid, then the sensors can detect where the problem is. So we can just shut down only that particular part of the grid and keep the whole grid, rest of the grid active, so that almost everything is working safely except where there is fault. So we can attend to the fault and keep the things active all the time. Another example will be wireless sensor networks that combine specialized transducers with communication infrastructure for monitoring, recording conditions at diverse locations. So usually, if we are interested in monitoring the weather or any such thing, then we need to put sensors all around the whole area at a given distance, all spread out in the form of a grid. But the problem is how to collect the information from these devices. One would be wired connection, but it's going to be too costly, and definitely it is not user friendly. We can't guarantee that the things will be always in order. Anything can damage it. So the best way is to make sure that each device is connected to the central unit through radio communication. So that we have sensors, um, a large number of sensors spread out in the geographical area, and then these are connected through network, and the network is using wireless connectivity. So we can call this a wireless sensor network, and this is very commonly used in uh, measuring, monitoring the weather conditions and all that. So it can be very much helpful in giving alarm in advance if any calamity is going to happen, and so on. So this today, thanks to the IoT, the whole things have become very cheap because the number of users. Sometime earlier, it was only the activity of industries, but today each individual wants to interact with these sensors, want to use the sensors for some or other application. Therefore, it has become a hobby-like thing today. Therefore, the requirement has grown, and because requirement has grown, now industry is ready to mass produce these sensors. And because of mass production, the cost of the sensors have come so low that anybody can afford any type of sensors anytime. A lot of sensors are available, like temperature sensors. We can have distance sensors using IR or using ultrasonic. We have gyroscope, accelerometer, rain sensor, soil moisture sensors, water flow sensor, heartbeat sensor, alcohol sensor, color sensor, PIR sensor, gas sensor, smoke detector. Then we have humidity sensor, flexibility sensor, touch sensor. Yes, of course, touch sensor is most commonly used. So you just touched your mobile phone to switch it on. Yeah, touch sensors, solar light sensors, metal detectors, real-time clock sensors, vibration sensors, and many more. So today, our whole life is surrounded with these sensors, knowingly or unknowingly. Just a pocket in your pocket is having a mobile phone, which is using almost many of these sensors, and unknowingly they are doing a lot of work. They are providing a lot of service to us. So as an example, to end upon sensors, how sensors are helping our lives to make better. Let's look at automation done to the automobile industry. So we have so many uh, situations where we need to sense it. So we just want to look at various activities, like the suspension system is there. Then we have seat belt, shift, gear shifter, gear position, interior control, steering column switches, mirror memory sensor, power steering, pedal sensors, headlight labeling, and many more. So what going to happen? say in today's car, if you look at it, we don't have to make sure that the safety is taken care, because the engine is not going to start till the seat belt is used. So as long as the driver doesn't wear the seat belt, the engine doesn't start, or it starts giving alarm, so shout so much that the driver is forced to wear the seat belt. Now, how does the car knows whether the driver is using seat belt or not? Of course, so there is a sensor with the seat belt. So when the seat belt is pressed into the hook, the sensor inside the hook will make sure that it is placed. But it can be done without a person. Just you can just pull the seat belt and hook it. So that's what commonly used to do earlier. But now the more intelligent cars are looking at how long the seat belt is pulled. So it should be pulled sufficiently long enough so that a person, it wraps around a person. If you don't pull it sufficiently, then it makes out that the person is not supported by the seat belt. It's just hooked behind him. Therefore, again it starts alarm. On the other side, the driver is okay, but how about the person sitting next to the driver? If the person sitting next to the driver doesn't wear the seat belt, again alarm. But how does it know that there is a person sitting on the seat next to the driver? Yes, of course, when person sits onto the seat, there will be weight onto the seat, and there is some weight sensor below the seat. And when the weight of the seat is more than what normal used to be, that means when somebody sits on that, the weight will change, and with change in the weight, it expects seat belt to be worn, and if seat belt is not worn, definitely that's going to create problems. So that way, at every stage, every part of the vehicle is under the supervision of sensors. So today's car is working under at least 5 to 10 processors inside, each one taking care of different activities, whether it or some processor is taking care of the working of the engine, something is taking care of the braking system, something is taking care of the electrical system, some processor is taking care of navigation system and all that. So while doing that, it is made sure that the inputs are available, and these inputs are made available through sensors. So we can't imagine our life without any sensor. Yes, I am talking to you because my voice is sensed by an earphone, and my image is being captured by a CCTV camera. So without that, it would not be possible for me to talk to you. So that's some introduction about the sensors. We have a big world of sensors, big. If we start discussing about the sensors, then it's going to be another series. So hope I can get into another series about sensors and actuators. That will be another interesting story. So thanks. That's all for now.